All right. So we're adding up the two. So all the reduction potentials are off one direction. In fact, all the reduction potentials are too low. All the oxidation potentials are too high, I think. Something like that. You know, one's one way, the other's the other way. But when you add them, those errors cancel out. When we add them, we get the cell potential. So the correct answer is A. 0 volts means the battery's dead. That is, the cell is dead. There's no potential for pushing the electrons across the circuit. Because this is our Kelvin, this is our absolute potential, not our relative potential here. And so that might change your further reactions. 2, which is the larger reduction potential? A or B? A. A's a higher potential. This is what we call 0.05 volts greater than H plus. And this would be minus 2.12 volts lower than H plus. 3, actually maybe I should see. How many, which is the larger cell potential? A, 0.95 volts, or B, minus 1.1 volts? How many people picked A? How many people picked B? Okay. Here, B is the correct answer. A is the wrong answer. B is the correct answer because when we're looking at the cell potential, you know, again, it's canceled out. So what we're looking at is pushing 1.1 volts. It's just the person hooked up the voltmeter backwards. If you hook up the voltmeter backwards, then it's pushing it right to left rather than left to right, you know. And so the voltmeter is just going to measure that. The voltmeter measures the absolute pressure on the electrons, or the force. That's what they call the electromotive force. Pressure is force per unit area, and so it's kind of similar in that sense. And so, which one of these is a larger force pushing electrons? I don't care about the direction. This plus or minus just tells me, you know, compared to on the voltmeter, what direction it is. Whereas this plus and minus tells me something else. This plus and minus tells me. Okay, or this could mean something else when we get to electrolytic cells. You know, this could mean that the reverse cell, if you tried to make it, would work out okay at 1.1 volts. Okay, 4. Here I can tell under standard conditions, 1 molar, 1 molar. This is standard. And so this should be E naught with a little superscript. Is what? Well, oh, actually, shoot. That was the question. I should have read the answer first. So what did you guys get here? E is equal to A. A. E is equal to A. I mean E naught. It's under standard conditions. 5. What is the potential? This is called a reduction potential or an oxidation potential. This is a reduction potential. So E is equal to E naught of reduction. Or E is equal to E naught of the anode. Oh, is that right? Does reduction occur at the anode? No. Come up with a mnemonic. Oxidation always occurs at the anode. So figure out some way to remember that. Well, the easiest way to remember it is A comes before C. And when we look at the cell, A is on the left, the anode, C, the cathode's on the right. And electrons flow from left to right, so oxidation always has to occur at the anode. Well, anyway, let's continue on here. This is a reduction or oxidation potential? Reduction potential. Is this under standard conditions? No, it's not. So E for this is, hey, is it A? 0 volts? Why isn't it A? Didn't we just say that this is defined, H plus is defined at, is the definition for 0 volts? At standard conditions, right. And so it cannot be A. If this would be A if I just change this to 1, and then it would be A. Then we would be good. So we got B, C, or D. And I heard what? Celine, you said, which one? B. You said B. B is the correct answer. B, because, you know, we got, rather than having 1 molar, we got 2 molar of oxidizer in here. If we got 2 molar of oxidizer, it's going to be a stronger pull for the electrons. So it should be greater than 0. That's good. 6. This is oxidation. A standard oxidation potential is how we'd read that. And so standard oxidation potential. Less than 0 volts means oxidation is non-spontaneous. True or false? Okay, how many people pick true? How many people pick false? It looks like most people pick false here. B is the correct answer. We don't know, you know, if it's spontaneous or non-spontaneous until we look at the reduction, right? When we look at the reduction, then we can figure it out. But there's no reduction. We don't know what the reduction is. And so, in other words, what is this oxidation? What is that? Is that the oxidizing agent? When we look at this, this tells us the strength of the oxidizing agent or the strength of the reducing agent. This tells us the strength of the reducing agent. And so this is the anode. We don't know what's in the cathode. How strong of an oxidizer is pulling the electrons through the external circuit. That's going to tell us whether it's spontaneous or not. Because this just means it's weaker than hydrogen as a reducer. Number 11 you should be able to answer too. Okay, what are we going to put in the anode here? What goes at the anode? The reducer. What goes at the cathode? The oxidizer. What's the reducer? What's the oxidizer? Well, actually, maybe you need more time. The reason I thought this was easy was because we did this one. We drew it on the board at the beginning. But take a minute, look at the diagram. I shouldn't call it a diagram. What should I say? Take a look at the sketch of the cell, and then see what's happening in that cell, and then try to answer number 11 and number 12. 11 and 12, you should be able to answer. So think about it. The reason I'm talking about the pace here is because the final exam I put in quite a lot of multiple choice. We have 3 hours. I think there's going to be about 60 multiple choice in 3 hours. So that gives you 3 minutes per multiple choice, or less than 3 minutes, because I'm going to have some reactions there. And so you want to pace yourself. You want to take, so let's do 2 minutes per multiple choice. Or let's do a minute and a half. Let me give you 3 minutes. There's no calculation involved here. But then I want you to review the cell, the drawing we did. And so you can try to figure it out.